Welcome to clickmyproject.com. Now we discuss about effect of load power factor on voltage stability of distribution substation. In this paper, voltage stability of the distribution substation is analyzed by simulation. Our main aim is to maintain the voltage stability of the distribution substation. Here we are going to determine cross point of the power grid transmission characteristics and the load reactive power voltage characteristics. There are two main effects on voltage stability or rise of the reactive power voltage characteristics of the load drop of reactive power voltage characteristics of power grid. Finally, we relapse in voltage stability of the distribution substation. The basic function of voltage regulation in the distribution system operation is to keep the steady state voltage in the system stable within an acceptable range all the time. The desired voltage can be obtained by either directly controlling the voltage or by controlling the reactive power flow that in turn will affect the voltage drop. The equipment normally used for the voltage and reactive power control are on load, tap changer, transformers, switched shunt capacitor and steps voltage regulator. Such equipment are mostly operated based on assumption that the power flows in one direction only and the voltage decreases along the feeder from the substation to the remote end. Voltage and reactive power control involves proper coordination among the available voltage and reactive power control equipment. Many distribution network operators operate such equipment locally by using conventional controller to maintain the voltage in the distribution system with the acceptable range and minimum power loss. Different methods have been proposed to improve the voltage and reactive power control in distribution system, both in planning and in the operation stage. In our paper, we use DVR to stabilize the voltage in substation. This is the flow diagram for our proposed system. In our proposed system, first we give the input. The input is the substation voltage and that input is called to the distribution network. The distribution network design is designed by Simulink model and then that output is in that using that distribution network diagram we draw the PV curve of power factor and PV curve of distribution network and the reactive power balance curve. Now PV curve of power factor will decrease the load power factor. It will not only lead to lower voltage quality and increased grid loss, but also reduce the grid transmission power. The PV curve with KPQ3 equaling 0.2, 0.4, 0.6, 0.8 respectively. The ratio of reactive with respect to active power increase due to decreased power factor. The maximum power transmitted from grid to the bus 3 is reduced. The Kp3 is the ratio of Q3 with respect to the T3. Then we draw the PV curve of distribution network assuming KQ3 is the ratio of Q3 with respect to P3. KQ-P3 is a constant with a certain power factor. When the bus voltage is constant, relation curve between P3 and U3 can be obtained, which is called the transmission characteristic curve of the distribution network, also commonly known as PV characteristics. When the bus voltage is 1.1, power factor of the load is constant and the ratio of Q3 with respect to P3 P3 is equal to 0.02. Now the PV curve will be draw that value. Now the reactive power balance curve. The minimum voltage is noted as a critical voltage. Taking the critical voltage point as a reference point, the load reactive power voltage curve is divided into two sections. The absolute value of PQ by dV in the left section is the greater than that its right section. In the steady state, the input power and the load power at the bus 3 is kept at balance. So the operating voltage of the bus 3 is determined by the cross point of the power grid transmission characteristics and load reactive power and voltage characteristics. Assuming that power grid voltage V0 is 1.1, for grid reactive power voltage curves are drawn in with a various ratio of reactive power with respect to active power. The family of curves are drawn together with the load reactive power voltage curve. The load reactive power voltage characteristics is described by a quadratic curve. The curve characteristic parameters are as follows: the rated voltage Vn equal to 1, the critical voltage Vcr equal to 0.75, the rated reactive power Qn equal to 0.2, and the absolute value of Tq by Tv in the left section is 2 times bigger than that in the right section. KQPQ equal to 0.2, 0.4, 0.6, 0.8 are the various ratio of reactive power with respect to active power for the grid reactive power voltage characteristic and are the load reactive power voltage characteristics corresponding KQPV. There are two cross points between the load reactive power voltage characteristic and each reactive power voltage characteristics. The cross point in the right section is the stable equilibrium point, and the cross point in the left section is an unstable equilibrium point. That there are stable equilibrium points for case of 4 power factors, but the operating voltage is reduced with reduced power factor. There is a stable equilibrium point between the load reactive power voltage curve and the grid reactive power voltage curve, which indicates the bus 3 static voltage stability condition. We draw the PV curve and of power factor and PV curve of distribution network and reactive power potential curve. We use that curve to find what is the stabilization voltage in the system. Now I go to explain our Simulink model. First we give the 120 voltage from voltage grid, it's the voltage source, and then it will be go to the bus 1, and then it go to the step down voltage, step down transformer. That step down transformer, the voltage will be reduced 110 to 40 volt. Then it will be in separated in two lines. Each line will go 353 km transmission line, and then one is directly go to the step up voltage, and it will step up the voltage from 40 volt to 110 volt, and then it will be go to the base 3, and it connected the linear load, and another line will go to the 350 km line transmission line, and it will be go to the base 3, and it then step up by 40 volt to 110 volt, and then it will connect at the DVR circuit, and then it will connect the linear load. If we run the project, we run our Simulink model. If they directly connect the linear load, the voltage disturbance is there in scope, and same time we connect the DVR, the voltage disturbance not there in line. Then the PV curve of the power factor and the PV curve of the distribution network and the power balance curve of different KP3 value, it will be shown in separate window, and that power balance curve will help to find what is the stabilization voltage and what is the unstabilization voltage of power system based on the critical voltage. Thanks for watching video.